Question 1A. Question 1A on inorganic chemistry. What we are dealing now is what? Inorganic chemistry. And my name is Easy Learning, Mr. Easy Learning. And this is inorganic chemistry. And looking at this, there's a question number 1A. List the 4 quantum numbers. They said what? List the 4 quantum numbers. Tell what each identify, and state the values that each may assume. How many things did they say we should stay here? They first said list the 4 quantum number. You have to list the 4 quantum number. Then after you have listed them, tell what each identify. What each identify. You have to tell us what each identify. And state the values that each may assume. That's 3 questions in one. This question is what? 3 questions in one. Listing the quantum number, tells what each identify, and states the values that each may assume. Then B, what types of orbital is occupied by an electron with the quantum numbers n equals to 3, L equals to 2. That's the question. Then the second question here, they said, how many degenerated orbitals of these types are found in a multi-electron atom? You now see that this question is what? 2 questions in one. They said, first of all, said what types of what orbital is occupied by what electron with a quantum number n equals to 3, L equals to what? 2. Then how many degenerated orbital of these types are found in multi-electron atom? C, question number 6 said, write 2 possible sets of quantum number to describe an electron in a 3s atomic orbital. We start from solution. Where's the solution? Quantum numbers. First of all, trying to let us know what quantum number is. We say quantum numbers are those numbers used to describe energy level in the what? Electron what? Orbital. We said quantum numbers are those numbers used to what? Describe energy level in the what? Electron what? Orbital. We now started to solve the question. And I started from the question A, 1A. They are, what are they? They are, they said list 4 quantum numbers. And I said A, they are I, the principal quantum numbers. The principal quantum number, which is denoted by what? N. Principal quantum number is denoted by N. And II, angular momentum quantum number, or what we call what? Subsidiary quantum number. We said angular momentum quantum number, or subsidiary quantum number, or azimuthal quantum number. That's azimuthal quantum number. So these are the names. We can call it angular quantum number, or subsidiary quantum number, azimuthal quantum number, which will represent with what? P, which we call L. This L is what they are writing this way, L equals to 2. That's the azimuthal quantum number. That's what they give me here as 2. And then this man becomes what? Principal quantum number. They give it to me as 3. And they give me azimuthal what? Quantum number, or angular quantum number to be 1, 2. Then I go to number 3. I say I, magnetic quantum number, which will represent with what? Capital M, with the magnetic quantum number. Then I say IV, the 4th one, because they mentioned 4. The 4th one is a spin quantum number, which will represent with what? Capital M and subscript what? X. Then I start to explain. They say list it. We have listed it 4 of them. So this one have been answered. We have answered this one. Then now they tell us, text what each identify. what each identify, and the value that each may what assume. And I said, the principal quantum number or Bohm's quantum numbers determines the energy levels. That means this principal quantum number determines the energy levels or share in which an electron is located. He determines energy levels and what share, either energy level or share in which an electron is what located, and its value determines the energy of any one electron atom of nuclear charge Z. Then when I said this, what this is telling us, text what each identify. We have what said that this man identified, this man determined the energy level or share in which an electron is located, and its value determines the energy of one electron atom of nuclear charge Z. Then when I come to the third question, they said state the value that each may assume. Look at the value this man will assume, the principal quantum number we assume. He said it has a value n, taking 1, its value starting from 1, 2, 3, 4, etc. to the infinity. That means that it has a value that starts from 1. Its value starting from 1, 2, 3, 4, and so on. Its value cannot be 0, but it's starting from 1 upward. So that's the value he takes. He said, state its value each may take. This is the value this man takes. Angular momentum or azimuthal quantum numbers. Angular momentum or azimuthal quantum numbers represented with what? Example L determines the angular momentum of the electron and the energy subshell. Energy subshell in each electron shell. And this is the two things this man does. He determines the angular momentum of the electron and the energy subshell. We have main shell and subshell. Energy subshell in each electron shell. We're going to see what we mean by subshell later. Full stop. The next thing is his value. He has values. Look at it. It has values equals to 0, from 0, 1, 2, to what? Dot, dot, dot mean what? Continuing to what? N minus what? 2 into N minus what? 1. That's how his number continues. Full stop. There's where the question given to us what? Stop. Look at where this man question stop. We have explained the angular momentum. He said it determines the angle, and it determines the angular momentum of the electron and the energy sub level in each electron shell. Sub level in each electron shell. And it has the values of L equals to 0, 1, 2, dot, dot to the N. Look at the generator, the one that generates its values. So that's the end of the question. Then let us look at why this man has angular momentum. Somebody will now ask, how does we say that he has angular momentum? Do you understand? But in your level, in O level, we talk about only azimuthal quantum number or subsidiary. That's what we call it. Either subsidiary or azimuthal quantum number area O level. But now you have come to advance. So when I call it angular momentum, how does it have angular momentum? We said, since an electron moving in a circular orbit has angular momentum. You know that when you are moving in if you are moving in a linear motion, you are going to have what we call linear momentum. As I'm running now, I have linear momentum. What's that my linear momentum? My mass, the mass of my body times the velocity which I use to run, give me the linear momentum. Then if an object is moving in a circular motion, in a circular orbit, it's going to have as well what we call angular momentum. Are you saying that? So now, when I say it must also have kinetic energy. So for something to move in a circular orbit, you must have what? Kinetic energy. Due to it what? Angular motion. As it's moving in a circular motion, you must have what? Angular momentum and also kinetic energy. That's what we identify. When I say the magnitude of this angular kinetic what? Energy must be limited by the total energy of the electron. Must be limited by the total energy of the what? Electron. The number of the what? Energy you have is what transform into your what? Angular momentum. When I come here to say, since n, which is called principal quantum number, n stands for principal quantum number, determines the energy of the electron. The allowed, that is the energy of the electron, the what allowed. But they will not say determine the energy of the electron. The allowed value of the angular momentum quantum number, must be restricted by the value of n. Since this man determines the energy level, which is the principal quantum number, that means this man have to be restrict the value of the angular momentum. Do you understand? Angular momentum quantum number. So talks will not say that angular momentum quantum number, which is this, is now 0, 1, 3, 2, 3, ... and n minus 2, which is this man is one that determines his value, because he is the one that determines the energy level, and the energy level is what determines the kinetic energy, and the kinetic energy is what determines the momentum, angular momentum you possess. Therefore, this man now determines this man. So that's how we now say, and the numbers 0. Look at the important thing. The number 0 of the angular momentum, and the 1 of the angular momentum, and the 2 of angular momentum, and the 3. How many numbers did I mention here? 1, 2, 3, 4. And we started from what? 0. Represent what? Subshell. Are referred as what? X, P, D, and what? F. What do we say we refer it to? We refer it as what? X, P, D, F. How many are there? 1, 2, 3, 4. This man now stands for 0. This man stands for what? 1. This man stands for what? 2. And this man stands for what? 3. That's what I said. How many did I mention here? What here? 1, 0, 1, 2, 3. And how many are there? 1, 2, 3, 4. So 0 stands for what? That L. This angular momentum 0, being 0. If angular momentum is what? 0, that means we are talking about what? X orbital. If angular momentum is 1, this L is equals to 1, we are talking about what? P orbital. I think you are following what I'm talking about here. Then if this man is 2, we are talking about what? D orbital. Then if it is a what? 3, we are talking about what? F orbital. Then we now say they are representing what? X, P, D, and what? F. Subshell. Have you seen what I said here? Sub what? Shell or energy sub level. Subshell or energy sub what? Level, respectively. So this angular momentum 0, 1, 2, and 3 represent what? The what? Subshell, which you will call what? X, P, D, F orbital. That's what this man represents. When I come to what? I think you have to see the reason why we call it what? Angular momentum or azimuthal what? Quantum number or subsidiary quantum number. That's what we can call this man. Then we'll come to I. We say magnetic quantum number. Magnetic quantum number, which will represent with what? M. When magnetic quantum number is represented with M. We say this man, magnetic quantum number, determines magnetism, determines the what? The magnetism and the number of orbitals. He determines the magnetism of the electron revolving in a what? Circular, and the what? Number of what? Orbital are in each energy sub level of what? An electron. So we say that this man determines the magnetism and the what? The number of orbitals are in each energy sub level of an what? Electron. This is what this man does, and that's what this man what a magnetic quantum number does. He determines this. So now we said again, the second question, the third question there said, what value does it take? We said it has integral. He has an integral values ranging from what? minus 1 through 0 to 1. That's me. Minus 1 through 0 to 1. That is, what did I say here? That is, look at its value. Magnetism. That's magnetic what quantum number. M, take its value as what? 0, minus 1. He started its value from what? Minus 1, 0, and 1. He started its value from what? Minus 1, 0, and 1. That's where this magnetic quantum number take its value. Its value is only 3 number. Minus 1, 0, and 1. Are you get what I'm saying? That's the value of this what? Magnetic what? Quantum number. Note that there are 4 subshells. There are 4 subshells. Are you get what I'm saying? X, P, D, and F, which we have mentioned. X, P, D, and F. The P subshell, look at it, has 3 P orbital. The P subshell have what? 3 P what? Orbital. Go look at it. P subshell. Go look at it. How many electron is here? The electron spinning. That's what we call spinning in. And the next one is to spin out. These 2 electrons. Spin in, spin out, 2 electrons. Spin in, spin out, 2 electrons. We now check it. 1, 2, 3. Mean 3 times 2 give me 6. That means that P subshell will take the maximum of electron of what? 6. The P subshell will take maximum of electron of what? 6. And this subshell, look at the subshell. 1, 2, 3 has 2 what? P orbital. That's the subshell. And it has a what? XP, PX, PY, and PZ. Then we now say the maximum electron which P orbital takes is what? 6, which we have said here. We now come to what? X subshell. X subshell has only one X what? Orbital. X subshell has only one X orbitals. Look at X subshell. How many electrons that you see here? 2. He's spinning and what? Spin out. That implies X orbital take the maximum of electron of what? 2. We now say that the maximum electron X orbital take is what? 2. Then we'll come to D orbital. D subshell. D subshell has a 5D orbital. 5D orbital. Look at the orbital. 1, 2, 3, 4, 5. 5D orbital. Then this D orbital, this subshell has how many orbitals? This subshell has how many orbitals? 1, 2, 3, 4, 5. That's 5 orbitals. And this total of the 5 orbitals will take 10. Look at it. 2, 2, 2, 2, 2 electron. 2 electron here, 2 electron here, 2 electron here. Check it. 2 times 5 will give me what? 10. That means that D orbital take the maximum of electron of what? 10. And the F orbital, you know that we have F orbital. F orbital take maximum of electron of what? 14. F orbital take maximum of electron of what? 14. He has how many subshell? He has 7 subshell. 7 subshell. That's what the F orbital has. He has 7 subshell. Why he has maximum of electron of what? 14. We now come to what? The maximum electron of the orbital takes is what? 10. We have settled that. And I come to IV, which we call what? Spin quantum number. Spin quantum number, which is what? Capital M and the subscript what? X. This X stands for what? Spin quantum what? Number. And it's what? It determines clockwise and what? Anti-clockwise spinning of what? An electron. This was spin quantum number. It determines the clockwise or anti-clockwise spinning of what? An electron. This is what this man does. This is what he does. He determined what? Clockwise and what? Anti-clockwise spinning of what? An electron. And what value does he have? He said it has only 2 possible what? Value. The value that he has. It takes what? How many value does it take? He takes what? 2 possible what? Value. What's that 2 possible value he takes? He has or he takes is what? Positive 1/2 and what? Negative 1/2. That's the 2 value this man normally what? Takes. He takes 2 value which is what? Positive 1/2 and minus 1/2. And this positive 1/2 donate what? Clockwise. And the negative 1/2 donate what? Anti-clockwise spinning. So the positive 1/2 donate what? Is denoting what? clockwise, and the -1/2 denote what? Anti-clockwise spinning. So this the true value this man takes. Let us explain more of what we mean by spinning. What do we mean by spinning? Let us explain more of what spinning. I say careful analysis reveal that many spectral line which appear to be what? Be simple are actually two lines. When we say line spectral, we look at it as being like one, but they are not one, they are two. Very close, are two lines very close together. Full stop. This phenomena is due to fact that an electron can spin on its own axis as it revolves around the nucleus, just as the Earth spins on its own axis as it revolves around the sun. In the case of what? Electron, it can spin either clockwise or anti-clockwise. That means electron can spin what? Clockwise or anti-clockwise. And that's what we see what? Spinning in and what? Spinning what? Out in a burst of the what? Subshell. Then I say it again. If it spin in, what it here? We say if it spin in the same direction as the direction of its angular motion, as its what? Angular what? Motion, it will make a slight addition to the energy. If it spin in with the same what? Direction of angular motion, it will have a slight what? Energy what? Addition. And if it's in the what? Opposite, if it is in opposite direction, there will be a slight decrease in the what? Energy. So if this man is spinning and this man spin what? Out, there will be a what? A slight decrease in the what? Energy. What? Slight what? Decrease. Slight decrease in the what? Energy. That's why we see this. But if it spin the same direction, there will be what? Increase in what? Energy. Do you understand that? But when it spin in a different direction, there will be a slight decrease in the what? Energy. This effect, which you see, this effect, although extremely what? Small, account for the what? The double line we observe. The double line we what? Observe in the what? Line spectrum. With a line spectrum, you are going to be seeing what? Double line. But it seems like it's a what? Single line, but it's a what? Double line. That what constitutes this double line is what? This is what? Spinning in and spinning out of what? Electron. Constituting of what? Dropping the what? The energy of this what? In spectrum and causing it to have a double what? Line. But in visual, we observe it as what? Single line. But it's a what? Double line. That comes to the end of it. And now come to what? Question number B. Let us come to question number. You know that these are not among the questions they ask us. These are not among the questions, but I use it to explain to you why we have a double line in the line spectrum, so that you'll be able to see the reason why we have a double line in the line spectrum is as due to what? The double, what we call spinning and spinning out of what? Electron, which reduces the what? The energy level, the energy in the what? Orbital, and constitute the double line. Then I now come to what? B, question number B, which is the real question they ask us. But before I go to next question number B, there are some certain things we needed to recall before we answer question number B. There are some certain things we needed to know, to note it out before we answer the question number B. Question number B cannot take us more than 2 minutes. We answer it. But before we can answer it, we have to note some things and look at them. I say recall means that you should remember that when we say that what we call what? Angular momentum is equals to 0. It is called what? X orbital. When this man L is equals to 0, it's called what? X orbital. And when L is equals to 1, this angular momentum is equals to 1, it's called what? P orbital. And when it is called, when it's what? Angular momentum L is equals to 2, it is called what? D orbital. And when it is what? L equals to 3, is called what? F orbital. You have noticed this. This is the major important thing. When I was talking about subshell, we said the subshell, which is constituted by what we call momentum, angular momentum quantum number, which is L is equal to 0, is called X orbital, and when L is equal to 1, is called P orbital, and when this man is called 2, is called what? G orbital, and when it's what? L equals to 3 is called what? F orbital. We have noted it with the subshell. When n is equals to 3, which we call principal quantum number, equals to 3, and the angular momentum quantum number equals to 2, we means that the electron occupies 3d orbital. This man is 3, and this 2 stand for d. That means what? 3d orbital. That's what the electron occupies when n is equals to 3 and the L is equals to 2. When n is equals to 4 and the L is equals to 1, we means that the electron occupy 4p. What is 1? 1 is what? P. And this man is what? 4. We call it 4p orbital. You know that this angular momentum is one that determines the what? The orbital, while the what? Principal quantum number determines the coefficient. The coefficient, which is the energy level. Then when I said I, when n is equals to 5, L equals to 3, we means that the electron occupy 5. 3 means what? F orbital. F orbital. Then when I come here and say, when n is equals to 2 and the L, which is angular momentum quantum number, is equals to 0, we means that the electron occupy 2x what? Orbital. Then I said, note that the number of degenerated orbital, the number of what? Degenerated what? Orbital of a multi-electron atom is equals to what? 2 n raised to power 2. 2 n raised to power 2. What's the n? The principal quantum number. That means principal quantum number determines the what? The number of what? Degenerated what? Orbital. So for n equals to 3 and L equals to what? 2, the number of degenerated what? Quantum number, which is only determined by what? The principal quantum number, is equals to what? This n now is 3, we'll put 3 here, become 3 raised to power 2, give me what? 9. 9 times 2 give me what? 18. That means the number of degenerated what? Quantum number of n equals to 3 and L equals to 2 is what? 18. Let us look at hydrogen at its what? Ground state. Let us look at hydrogen in a ground state, so that when a question is asked us on that kind of question, we'll be able to answer it. We said, for the hydrogen in ground state, what does it mean? For hydrogen to be in a ground state means that n, principal quantum number, is equals to 1. And what? Principal quantum number is equals to 1, and the what? Angular momentum quantum number is equals to 0. That's what means that what? Hydrogen in a ground state. If an atom is in a ground state, this one is 1 and this man is 0. Means that hydrogen electron occupy 1x what? Orbital. This man is 1 and this man is what? Being 0 means what? X orbital. This also means that hydrogen has no angular momentum. That means angular momentum is equals to 0. Meaning that hydrogen has no what? Angular momentum or azimuthal what? Quantum number. Angular momentum quantum number or azimuthal quantum what? Number. Then when I say, which is this, right? And so, look at the azimuthal quantum number. And so that orbital does not depend on angular coordinates. That means that what? Hydrogen atom, the orbital does not what? Depends on what? Angular what? Coordinates. When we are talking about what? Hydrogen atom. That's what additional information I want to give you, so that you will know when we say that an atom is in a ground state, it means that n is equals to 1 and what? The angular momentum is equals to 0. Let's go to question B, which they asked us, the main thing we are after. They said what? what types of what orbital is occupied by the what electron with what the quantum number what n. Now we can answer the question. I think you know what type of what orbital is what occupied by an electron with what the quantum number what n equals to 3 and what l equals to 2. That's the question they asked us, and they said again how many degenerated what orbital of this type are found in a what multi-electron what atom. But look at it. The solution to question number B, when I said I will bring the question close so that you'll be able to see it and see what it means. We have learned about this. Then N stand for what? Dates, and this man stand for what? What does it stand for? 2. We say 0 stand for what? X orbital. 1 stand for what? P orbital. And 2 stand for what? D orbital. Then what do you mean? What the types of what orbital is what? 3D. This man 3 and the what? 2 mean what? 3D what? Orbital. That's settled the question. Where the type of orbital that will occupy by these people is what? 3D orbital. That is our answer for that one. That's our answer for that one. The second one, the generated what? They said the number of what degenerated what orbital is equals to what? 2n raised to power 2. And we have said it before, 2n raised to power 2. We have learned it before we read to this. And this n now is what? 3. Look at it. This n is what? 3. Because it's only principal quantum number that determines the what degenerated what orbital. And I put the 3 here. 3 squared will give me 9. 9 times 2 will give me what? 18. And that's my what? Answer for the second question. Then when I come to question number C, what they asked us. Question number C, they said, write 2 possible sets of a quantum number to describe and what? An electron in a what? A 3x atomic orbital. How do we describe this man? Who and who is involved? 3x orbital. This 3 stands for what? Quantum number equals to what? 3, right? And the x stands for what? What we call what? Angular momentum quantum number equals to what? 0. That is for x. And that's what we say here. We said what? What did I say here? I said the 2 possible quantum number that describe this man. Look at the man. Can you look at here? Look at the man. They say the 2 quantum number that describe 3x what? Orbital or 3x atomic orbital is what we call principal quantum number, which is n equals to what? 3, and the angular momentum quantum number equals to what? 0. This is the 2 persons that describe this man, and from these 2 persons we have this. So when we are preparing this man, we are preparing what? Well, my principal quantum number and angular momentum quantum number, which is equal to 0, and this man equals to what? 3. And that's our answer. You see that the question B and C is as simple as ABCD. But if we didn't what go into detail knowing all these things, you can't be able to what answer this question. That's why we go into what first of all teaching you or from line to line so that you'll be able to what answer the question. Now you have known this. Any question that comes on this quantum number and the N and L, you can be able to what thank you it. If you have not subscribed to this channel, try to subscribe. We are good. Thank you for liking this channel. Thank you for what? For sharing it to your friends. See you in the next class.